What is a semantic kernel? It is a set of keywords which annotate the real definition of a product or a service in virtual space. Thus, a semantic kernel is described as annotation of a piece of knowledge. Usually at the moment we are embedding the kernel to website content. The simplest approach to consider the semantic kernel is to present the source text as a bag of terms, which is sequent clustering. As it was established, we should distinguish three clusters of terms: geography, product, and time. Slide number 3. Thus, the semantic kernel can be represented as a trigram or a set of three questions: what, where, and when. We present the attempt to describe the semantic kernel mathematically and algorithmically. We assume that we have e-content as a source material. In other words, we have a set of HTML documents as initial information. Each document contains many keywords. Therefore, two models are proposed in our work. The first model is focused on the processing the documents. The second model describes a set of keywords based on the typical trigram model. According to the first model, each document includes a set of sentences where each sentence is a union of three sets of keywords. The first set is the words that describe the product. The second set is an end of sentence character. And a third set are words that define the general meaning. In our case, it is advisable to remove the end of sentence character and leave only the first and third sets. In addition, the first task is to determine the document in which the main meaning or main description of the product is concentrated. So for the search engine optimization, it is advisable for us to identify in the e-content the documents where the semantic kernel is described. This is the first model and our first task. The second model, already described, describes the identification of those keywords that define the semantic kernel itself. We single out trigrams in the simplest case. The study showed that working with trigram does not work in most cases. At the same time, it is effective to use the so-called collocations or stable construction of two or more keywords. In the work, an analysis of the quality metrics of both documents and keywords was carried out. This analysis allowed us to refine the first and second models, sentences, and set of keywords. Slide number 4, sorry. On the slide number 5, you can see the list of metrics that will allow us to highlight the desired documents in the e-content and then the semantic kernel. On the slide number 6, a list of operations that we need to obtain a semantic kernel is presented. First, we perform lemmatization and normalization. This allows us to truncate the second set of characters in each document. We then process the selected documents to find collocation and aspect terms. Collocations are the first circle of the semantic kernel, and aspects will allow us to improve the kernel with keywords of general meaning. At the same time, in order to evaluate either a collocation or an aspect term, we use a special metric. That is one of those metrics that were showed on the previous slide. Then the algorithm of semantic kernel synthesis method, which reflects two processing cycles, is shown on the slide number 7. In the work, several experiments were carried out to highlight the semantic kernel. At what such isolation and application of the kernel on practice show it on a positive effect. On slide number 8, there is a graph of the traffic of a real web resource that provides an online service in the United States. The graph shows the moment when the semantic kernel was identified and applied in online advertising. The first cycle working with web resource document is also showed on the slide number 8. It can be seen that the kernel was located on the contact page. On slide number 9, a fragment of e-content is shown that is real sentences with a semantic kernel. Further, on the slide number 10, we already see the process of extracting the items, keywords. As a result, 10 keywords were obtained that were applied in the search engine optimization process. The results obtained should be analyzed. To do this, let's turn to slide number 8. Again, as we see at the beginning of 2018, this web resource is lost its popularity. An idea arose to identify the causes of this situation. According to classical method of search engine optimization, 3 approaches should be applied. The first is the e-content optimization, the second is online advertising, and the third is optimization of semantic kernel. It was decided to take the third path, which gave the following results. Firstly, from the point of view of the first approach, e-content optimization, the semantic kernel of the web resource should be placed as much as possible on the main page. As can be seen from the results of our study, it was not done. Moving the kernel immediately gave a positive effect. Secondly, the dedicated kernel was placed in advertising messages through the Google Ads service. Thus, the allocation of the kernel immediately gave a positive effect for this web resource. Thank you for your attention.
Thank you very much. But still, maybe somebody have questions to the. No, nobody. I have some, maybe from the start. Semantic kernel. What is it exactly? Cannot maybe. No.
Okay, thank you for the question. So actually we have classical methodology, search engine optimization. Inside this methodology, there are 3 actually approaches. First approach is this is HTML document optimization, semantic kernel optimization, and actually advertising, online advertising. What is a semantic kernel? Actually, this is a set of keywords which defines the reason of HTML document. And if we can operate with this semantic kernel, we can build actually search engine queries or search engine requests in order to have the first position at the end of our site.
It all connects with SEO, search engine optimization.
Yes, search engine optimization. Yes, this is the direction.
Semantic kernel is set of keywords. No, but what is semantics in this case? Because semantics it's connection between some semantic connection between some essences, between words, for example. Here, it's but again, when we describe document of set of documents, HTML documents. One semantic kernel can help us classify documents. It belongs to some set of HTML documents.
Yes, you're right. We can classify using this set of keywords the different documents, and also we can build right, how to say, content of our web resource in order to be on the first position in the answers of our search engine. For example, Google answers, if you put the request and you will receive the response, inside this response, your position will be the first or probably 5.
Okay, you defined semantic kernel for some documents, and where is physically placed this kernel? On the side of client or on server, or where? Where
yes.
is it?
Mm-hmm. So I understood. We have, how to say, 2 copies of this semantic kernel. One copy is stored inside your web resource on your web page, and another copy is inside your search engine database. And if we have the, how to say, the correspondence between these 2 copies, in this case, we will have the good results in the response of search engine.
Okay, understand. Maybe somebody else have questions.
Can I ask, Vadim Slusar?
Please.
What is different between your approach and semantic segmentation of text?
Actually, my approach more concerned with HTML documents, and we think about the, how to say, short annotation of the documents. But if we are talking about the segmentation, in this case, we classify actually like in library, yes, different documents according to some topics. This is a little bit another task.
Okay, thank you.
Thank you very much.
Thank you, colleagues, for the questions.
Yeah, thank you. If no any questions, we're going to next report. Next report, Bohdan Sus, Sergiy, Zagorodnyuk. Present any? Yes, Bohdan Sus, you have a word.
Yes.
Please share your screen and open microphone. The microphone is.
Oh, sorry. Can you hear me?
Yes,
yes.
we can hear you.
Yes. Greetings from Kyiv. Sorry for the total blackout of electricity. I will try to make the presentation now. Dear conference participants, dear scientists and teachers, I'm Bohdan Sus from Taras Shevchenko National University of Kyiv, and I'm pleased to present a paper optimizing the process of soybean oil epoxidation by the means of artificial intelligence. Authors Oleksandr Bauzha, Taras Chaikivskyi, Valentyna Maliarenko, me, and Sergey Zagorodnyuk. The researches have been made in Lvivska Polytechnica and Taras Shevchenko National University of Kyiv. An intelligent system for processing data of soybean oil with epoxidizing system with hydrogen peroxide, acetic anhydride catalyst was created. It allows researchers and engineers to control the epoxidation process at the stage of synthesis and to improve the technology of obtaining epoxidized products. Experiments on epoxidation process of soybean oil were performed in laboratory, and the scheme is based on a multi-layer artificial neural network for digital signal processing. Clear simulation on the effect of the initial concentration of chemical compounds on epoxidation process were analyzed by the means of an artificial neural network. Chemical process of epoxidation of vegetable oil by epoxidized system is presented on the slide. It contains hydrogen peroxide, organic acid, catalyst, and this system is based on a multi-layer artificial neural network for digital processing of experimental data. The multi-layered, fully connected feed-forward neural network architecture has been selected for the predictions. The artificial neural network received sets of values of variable, in particular values of regulating parameters. A sample of data for neural network training was devised from the experimental results. Inputs cover the initial acetic anhydride concentration, hydrogen peroxide concentration, and catalyst concentration. The inputs 1 and 3. All these inputs, the values of the concentrations of the obtained substances, and were normalized to a maximum value that was observed in the experiments. Input 4 is normalized temperature, and input 5 normalized reaction time. The outputs of neural network are the normalized values of epoxy number and iodine number. It is shown that the initial values of epoxy number and iodine number depend on the initial value of these values at the beginning of the experiments. Therefore, they are taken as inputs to beginning of the experiments. The neural network, after training, reproduce the study data from a sample of experiments and predicts the results of study in extended time range active add substances. The obtained predictions allow experimentals to select the most promising direction during the determination of the concentration of active add substances. This figure shows the dependence of epoxy number formed as a result of experiment, which is predicted to be formed as a result of training on a sample set of experimental data. Dependence of epoxy number on the concentration of the catalyst and time of soybean oil epoxidation reaction. The calculations were performed at the values of the concentration of the input substances for the corresponding temperature and presented on the slide. A comparison of the dependencies of epoxy number on time in minutes of experimental data presented by red lines and predicted data by the neural network presented by blue lines. The graph shows the dependencies for different concentrations of catalyst. As a result of training, the neural network processes the entered data quite accurately to predict the result of the experiment beyond the experimental date. This slide shows the dependence of iodine number formed as a result of experiment, which is predicted to be formed as a result of training on a sample set of experimental data. Dependence of iodine number on catalyst concentration and time of soybean oil epoxidation reaction. The calculations were performed at the values of the concentration of input substances for the corresponding temperature and presented on this slide. Comparison of the dependencies of iodine number in time and experimental data presented by red lines and predicted data presented by blue lines, the data calculated by the neural network. This graph shows the dependencies for different concentrations of the catalyst. This graphic shows the dependence of epoxy number as a result of experiment, which is predicted not to be formed as a result of training on a sample set of experimental data. This dependence of epoxy number on the concentration of catalyst and acetic anhydride, which correspond to 1 hour reaction, is presented on the slide. This figure shows the dependence of iodine number as a result of experiments, which is predicted not to be formed as a result of training on a sample set of experimental data. Dependence of iodine number on concentration of catalyst and acetic anhydride, which correspond to 60-minute chemical reaction. Conclusions in this paper. A method for finding parameters of epoxidation process of soybean oil has been presented. In this case, the dependencies on the concentration of acetic anhydride and hydrogen peroxide, the amount of catalyst, and reaction time. The implementation of neural network showed that even with a small experimental data set, it is possible to predict the quantitative result of epoxidation, especially epoxy and iodine numbers. The suggested approach makes it possible to obtain additional information about the course of the epoxidation reaction of soybean oil. The optimal conditions for the oil epoxidation process were established using the initial set of specific determined values for the concentration of acetic anhydride, hydrogen peroxide, catalyst reaction, duration, and temperature condition. So thank you very much for the attention. Thank you, European colleagues, for the support of Ukraine in such a hard time, and have a nice day. If you have some questions, I'd be very glad to answer.
Thank you very much.
Thank you. Actually, I found this paper very interesting. So from a chemical engineering perspective, and one question I have is about the error in the measurements. Normally, when you do real experiments, you have some error noise on the experiments. How do you process this in the neural network?
We don't have a lot of errors. Neural network accurately reproduced the experimental data. Sometimes we had overfitting, but we didn't have a lot amount of data that depends on the error behavioral. The more time neural network has been trained, the more accurately data has been reproduced. And these concentrations were checked experimentally on chemical process in laboratory and suit to experiments quite well. You can also ask Chaikivskyi about chemical verification of the data.
Okay.
But
Thank you. I was interested in this aspect because often this is a big problem when you do real experimentation. But as you said, apparently here the noise is relatively small. I also found the graphics that you produced quite interesting. In the graphics that we see right now, you have used some colors. Can you explain the meaning and of these colors? Is it indication of the height or
Different colors.
in the current plot?
Sorry, what explain?
So the colors in this plot, are they representing the height of the function? It seems like
yes.
It's iodine number. 50.
Iodine number.
Okay, so it's an additional visual aid. So
Yes, additional visualization.
But I have one question. It seems to me last year I already listened very similar report year ago about this oil.
Yes, we made some similar researches on the other chemical compounds. Maybe Taras Chaikivskyi can explain difference. We have completely different experiment, not on sets of soybean oil. It was also for catalysts, but for other chemical reactions. And,
yes, I will add something. Dear participants, we have neural network for other chemical process like cyclohexane oxidation, ethylbenzyl oxidation, and same process. And with cyclohexane or ethylbenzyl oxidation, we also have speaking about catalyst, about concentration of compound, and use neural network for optimization with technological process.
It was another process, but why you need this network, neural network model?
Bohdan,
Because
please show chemical reaction, please. I understand your question. Thank you for your question. Oh, look, for the left side, we have unsaturated bond, like in vegetable oil. Today we use soybean oil. Unsaturated bond will be destroyed and making epoxy round. It's needed for paint production, for paint factory. But we have two function, like epoxidic number is the number of epoxidic round in our mix, and UD number is a quantity of unsaturated bound. For the first time, we have no epoxidic and have more unsaturated bound, and we no need to fully perform all unsaturated to epoxidic, because unsaturated bound use to adhesive compound in paint, in glue, and we need a neural network like optimization method, like optimization for stop our reaction, and this time we have same quantity of epoxidic number and same quantity of UDD number as need this kind of paint, for example, or this kind of glue.
Okay.
Can I ask?
Thank you very much. Very short.
Could you give more information regarding your neural network architecture? What processing layer do you?
Okay, I will find the slide.
In my opinion, it's a very easy architecture. Maybe need more.
Yes, it's very easy feed-forward the neural network, but this simple structure was optimal for calculations with a small amount of input data. We didn't need to make more complicated architecture, because we didn't have a lot of data to learning.
What is the accuracy of your results?
Accuracy almost 98%.
Thank you.
Okay. We will have a round table, and that's the end of today.
Okay, thank you.
And we can discuss all the rest. Thank you very much. Then going to next report. Report number 9. Kostiantyn, Kostiukevych, Gordienko, Rokovyi, Stirenko. Anybody present?
Not that I see them. No, unfortunately.
Okay, then we will show video maybe.
Let's show the video.
I will look for it.
Number 9, hierarchy of
Yeah,
hybrid.
one moment. One moment, please. I will share screen.
I see him, Konstantin. Hello, Konstantin. He is online, trying to connect. Konstantin. Hello. I think the speaker is trying to connect.
I cannot see him.
Konstantin Kost.
I see him. And he also can.
Hello, can you say something? And there's also
Problem with sound.
maybe problem with sound. Unmute? No, he is unmuted.
He connected with mobile phone. I don't know.
Yes. So maybe we can show your video. You can write in the chat. If you, maybe the chat works. We can hear you not very good. So we propose to show the video and you can write in the chat the question or the answers.
When I start,
I'm sorry.
Can you listen sound? Or not listen?
Not, yeah, very bad in the moment. Did you switch it on?
One moment. I will try again. Okay.
Okay, please
Hello
look
everyone.
at the chat.
My name is Kostiantyn Kostiukevych, and today I'm gonna present our work, namely hierarchy of hybrid deep neural networks for physical action classification by brain-computer interface. Background of this research. So, basic task in electroencephalography brain-computer interfaces is decoding hand movement in order to classify movement in moment or classify its intention. There is widely used grasp and lift dataset which provided us to opportunity to build models and examine them. So combinations of deep learning components including 3 RNN families with hidden status, attention mechanism and various types of convolution layers and their impact on performance metrics was examined. Data and choices behind the data. So widely used grasp and lift dataset was used here, and it contains information about brain activity of 12% measured by sampling rate at 500 Hz in 32 channels of the recorded EEG signals. It contains data from the observed persons who sequentially performed 6 types of physical activities: hand start, first digit touch, both start load phase, lift off, replace and both release. The data pre-processing was used only to cut regions of interest that correspond to the actual human-computer interactions of users. Some action signals overlap and their classification become more complex because they were not presented separate. So classes which intersect with each other were excluded, namely first digit touch and replace. Mainly we compare 3 recurrent neural network variants: classical recurrent neural network, long short-term memory, LSTM, and gated recurrent unit, GRU, We combine them with hidden states at RNN layer, attention after RNN layers with hidden states, one-dimensional convolutional layers, two-dimensional convolutional layers, and versions where these convolutions layers were wrapped by time-distributed layer. For each RNN variant we have 15 following combinations, as you can see. Training environment. At each training epoch, the generators take data from each category from a randomly generated sequence. To diversify the data, it was decided to choose a starting point for the sequence to be used for training, validation, and testing in a certain range, randomly in the range of 10 measurements. The only present label was set a ground truth. The training, validation, and testing stages were performed at GAL grasped leaf dataset that was divided in proportion of 82%, 8.8, and 8.8 for training, validation, and testing sets accordingly. Finally, it allowed us to obtain trained models, calculate metrics, including area under curve, and its micro and macro versions. Experiments run within Kaggle IPython environment. And also you can see others hyperparameters which choose it to our models. Evaluation. The 5-fold cross-validation was applied. Area under curve macro values were determined for each fold, and the mean values were calculated for all AUC macro values determined for all 5 folds. Then the scatter plots for training time in records per training part of the dataset versus macro AUC values with the relative size of the models given as symbol size were prepared. The performance of several families of hybrid combination was measured and plotted. At the slide presented it scatter plot for gated recurrent unit family, and these results allowed us to make comparative analysis of the models used with regard to their performance and resources needed for model preparation, a training time, and storage, a relative size expressed by symbol size. To understand the complex relation between separate components and the whole hierarchy of the models used, the tree-like representation was prepared and given for all RNN families. The nodes in the tree-like plots denote the models created with the labels containing information about specific details about the components applied. The edges between nodes denotes hierarchical relationship between them. The size of the circles denote the relative size of the models. The results demonstrated on the tree-like plots allowed us to build hierarchy of the models and find some relationships between models that can lead to increase or decrease of the performance. So in RNN tree of models, some branches can lead to increase or performance, like pass from BRNN hidden states with AUC 7 with AUC 0.743 then it was wrapped by then added time distributed wrapper around one two-dimensional convolutional layer that lead to increase of AUC to 0.809, and when we stack on BRNN hidden states, we stack it with attention mechanism that lead us to AUC 0.85, but also it possible to decrease performance by adding some components, like in a variant where BRNN hidden status with AUC 0.743, we add time distributed convolution to the two-dimensional convolutional layers, and then instead of attention mechanism we decide to stack on top of BRNN with hidden states another time distributed two-dimensional convolutional layer, and that's lead us to decrease of AUC to 0.5. Yes. So discussion and further research. The attention in general, the attention mechanism after RNN layer with hidden states in all RNN variants increase macro AUC from 34% to 2% and slightly decrease training time. But using RNN layer with hidden states as input for last fully connected layers always give worse results. Using convolution layers as first layers can significantly decrease training time with preserving macro AUC, but using convolutional layers after RNN layers with the hidden states and attention just decrease number of parameters without boosting macro AUCs and training time. The work was supported by knowledge at the tips of your fingers, clinical knowledge for humanity. That's all. Thank you for attention.
Yes, something was written in chat, but I cannot understand. Kindly ask him to pause. What is means pausing? I don't know. Then Kostiantyn Kostiukevych absent or present? Absent. Sorry. Again, questions will be on round table.
I kindly ask to post questions. So he wrote, I kindly ask to post questions.
Okay.
So the question could be,
next time. Then, thank you very much. And says,
I have a question actually I want to put.
Yeah. Post questions in chat. Yeah, okay. But meantime, we should go to next report. Roman Dzhala. And who is present from this?
Hello, I'm present. Yeah.
Yeah. Please share your screen. Roman Mysiuk. Okay. Please.
Yes. Hello. Can we please play this recording, because maybe it would be better.
Okay,
Yeah.
we can
And
play the record.
Thank you.
And
I
you
will,
can
I will be here.
Okay.
One moment. Moment. I will share your report.
Hello to everyone, my name is Roman and our work is a simulation of corrosion fracture of nano-concrete at the interface with reinforcement, taking into account temperature change. And I would like to start with some introduction. So reinforcements for concrete constructions of the sewage network are made of steel. The efficiency of the system of transformation, cleaning, and disposal of dirty sewage depends on the thermal regimes of sewer pipes, which creates condition of potential environmental risks and emergency danger for the local population. Corrosion processes take place on the interface between reinforcement and concrete in underground sewer pipes, which are facilitated by soil moisture. The result of condition is the formulation of micro cracks and some cracks. So, and our outline contains 6 topics. The first one is purpose and task. After that, it's mathematical model for analyzing the influence of seasonal temperature changes on corrosion process and condition of concrete destruction. The next one is example of influence reinforcement concrete after corrosion in the metal surface in sewage network. And after that will be topic changes in indicator of anode current density according to the average temperature in Ukraine every month, and some difference between this value for the first and third year. And the last one topic, its conclusion, the purpose and tasks. So the purpose of this study is to model some like anodic current in a track-like defect on the interface surface on the reinforcement, and to study its influence on corrosion destruction of nano-concrete, taking into account temperature changes, the influence of mechanical loads, humidity, and diffusing oxygen. So to achieve this goal, there are several tasks. So that's prepare information for corrosion current, for thermal regime in surface defects and the interface with reinforcement, and to form criterion relations on a new mathematical model for analyzing the influence of temperature changes on corrosion process and condition of concrete destruction, and to form the criteria relations and optimization procedure of a new mathematical model for analyzing the influence of mechanical load and thermal condition on corrosion process and the condition of destruction of nano-concrete in the nano-concrete rebar system. So in general, the new mathematical model for analyzing the influence of temperature change on corrosion processes, which lead to the formation of corrosion pores at the interface between concrete and reinforcement is formulated here, and in particular the basis of the new model is the T-type ratio. T-type ratio for the anodic current density, and a new comprehensive straight criteria for concrete, as well as an optimization approach for calculation interconnected parameters using neural network and a quality criterion, and taking into account the inverse relationship between the material parameters and corresponding initial values. So we are taking into account Cauchy type criteria of Griffith, Irwin, or Orowan, and criterion of Straight here, as you can see, and some restriction, trouble tree operation, and multi-applicative qualitative quality criteria, and some criteria, quality criteria that is mentioned in the 7 formula, and some optimization of compressive straight, so as it's mentioned in the 9 formula. Okay, and an example of modeling the anodic current in defects on the metal surface in civil sewage network is considered. Constant humidity and temperature changes lead to the occurrence of corrosion processes, which cause the destruction of the structure over time. So the number of size of and number of the defects may increase under the influence of these external factors. Particular attention should be paid to places near stations or pipelines that are in a hot place. So since Ukraine is in temperature climate, there is an average temperature change of 279 Kelvin in the winter period and 294 Kelvin in the summer period. This temperature change causes defects to increase due to the change of state. So as you can see here, we have the difference value, like and depends on the month, can be changed, like for each month it's related to the average temperature. So, and here you can see some difference between these values, and the biggest difference, like in the values of the corrosion current is in the summer months and the smallest in the winter months. So here you can see some estimations of change. These indicators of like anode current density every 2 years based on the fixed calculated steps. So these values will increase every 2 years. And some conclusions here, that the first one is we have some changes in the like anodic current density in the corrosion pore or at the interface between nano-concrete and reinforcement takes a value of approximately 3% percentage, but it's enough to transform the pore into corrosion crack, and some mathematical model for analyzing the influence of temperature changes on the corrosion process is formulated here. So thank you for your attention.
Thank you. It's complicated.
Thank you. Thank you.
Thank you so much. Any questions to us?
Sorry.
Is there any question from the audience?
Yes.
Please. Otherwise, I have a question about the image data. So how do you get this data sets? So what is the method?
Okay, I understand what you mean. So basically, we have used some experimental data that we have measured before, like in real life. So we have used some devices to measure this current density on the some steels and sewage system, you know, and basically we use this data to simulate the process, how it will destroy during the time, and how average temperature can make some destruction, we can make some micro tracks in this system.
I thank you. I have actually some of my colleagues working on a similar project in Belgium. It's called Sewer Sense, and they also, with cameras, look in sewing systems to define some cracks and leaks. And I will send you an email that you can have a look at their work. And
yeah, that's so interesting.
It's from research from New Leuven in Belgium.
Okay.
But I will find it out for you.
Okay, so please put on this chat. Maybe I will find something interesting for us.
Sure. It will be good to connect.
Thank you so much.
Thank you.
Okay. Then we're going to next report. Dmitry Klushin present here. Dmitry Klushin. Non-parametric method of estimation of forecasting models using small samples. Absent again, sorry.
He is absent. So we can play the video.
Yeah, I should play video then. Moment, microclusion, yes.
Please, if you have any questions, write them in the chat and we can forward to him.
Yeah. Okay. Maybe Klushin wait 2 minutes and appears now, but he will be at time of questions.
Do you see him? If he appears during the presentation, we can ask him for the questions.
Yeah, okay.
Okay.
Dear colleagues, I would like to represent a new non-parametric test for estimation of errors of forecast models using small samples. The problem of forecast error estimation is formulated in the following way. Let Mj, where j is varying from 1 to m, be forecasting models producing predictions xij of data sequence xi, where I is varying from 1 to m, and epsilon ij, where I is varying from 1 to n, and j is varying to 1 to m. The errors of the models Mj obeying distribution function fi. Consider a loss function j dependent from the error epsilon ij describing model accuracy, for example, standard deviation. To compare forecast by their error measures, we must test whether the their distributions are equivalent. If the distributions are equivalent, we can distinguish the model. There are several error measures for forecasting. Mean absolute error, mean squared error, mean squared deviation, root mean squared deviation, and normalized root mean squared deviation. The hypothesis about similar accuracy of models MK and ML is equivalent to the hypothesis that the mathematical expectation of the difference between lost functions calculated for the errors AIK and AIL, respectively, for the models MK and ML, is equal to 0. Thus, the mathematical expectation of such lost functions are equal. If a loss function is a standard deviation, the problem is reduced to testing the hypothesis that the mathematical expectation of errors between two models are equal. Usually, testing equality of forecasting models accuracy is reduced to testing of this hypothesis. However, the hypothesis that accuracy measures obey the same distribution is more general. Thus, to test homogeneity, it is necessary to test the null hypothesis not only in partial case when mathematical expectations are equal, but in general case when the distribution functions are equal. Consider the background of the test. Let x and y are samples from distributions f1 and f2. Construct the variance series corresponding to x. The null hypothesis states that the distribution f1 and f2 are identical. If it is true, then due to the Hill's assumption, the probability that an element of the sample y is greater than the ith order statistics and less than jth order statistics, where I is less than j, is equal to j minus I divided by n plus 1. Let's reference it as an expected probability. If the distributions are not identical, then the observed relative frequency significantly deviates from the expected probability. Therefore, we must estimate the difference between them. To do this, we use the confidence intervals for binomial proportion with given significance level. Let n be the number of the confidence intervals containing the expected probability. The proportion h of the confidence intervals containing the expected probability is called p-statistics. It is an estimation of the probability that the samples x and I drawn from the same distribution. The next slide illustrates the errors of focus provided by the random forest model, KNN model, and gradient boosting model of the data on the data from Germany, Japan, South Korea, and Ukraine. These data were published in the paper Chumachenko et al. In the journal Computation in 2022. The selection of these countries was motivated by different character of pandemic dynamics in these countries and different anti-pandemic decisions made by their governments. This choice should mitigate the bias due to these factors. Note that this is not unique variance of the country's selection. For example, Papastefanopoulos et al. Made a comparison of 6 time series methods to forecast percentage of active cases per population in 10 other countries using the other criterion, the greatest number of total confirmed cases. Note that the size of this sample is small. To overcome this difficulty, we propose to use bootstrapping. This slide illustrates that all considered tests are equally successfully worked with data from Germany and Japan. The test successfully detected heterogeneity of the errors distributions of the 3 considered forecast models. Except in the Diebold-Mariano test, when the p-values is more than 0.05, in the case when we compare models K and N and gradient boosting. In all other cases, the models are different. In this slide, we see that for South Korea and Ukraine, all models are different from others. So, but we see that Reclusion, Petunin, Diebold-Mariano, and Wilcoxon has different p-values, such that we don't see the difference between models random forest, KNN, and gradient boosting, because the p-statistics is greater than 0.6, but other cases are did not see this difference. The experiments made using the data from Germany, Japan, South Korea, and Ukraine have shown that the proposed test with bootstrapping is more effective for comparing forecast models than the Wilcoxon signed rank and the developed Mariana test. The future work will be focused on the comparisons of the proposed test with other tests used in this domain and other countries, and on the theoretical properties of the p-statistics for the samples with unequal sizes. Thank you very much for your attention.
Thank you. Reporter not present now? Not. Then questions will be sent if somebody will want on the round table or to the post. Now we have some minutes to be prepared to next report. Report number 12. Oksana Markiv. You have 5 minutes in advance.
Okay, so should I start?
No.
Should I start? Yeah?
No, not start. A few minutes wait, please.
Okay.
We will about inclusion absent, yeah? Absent, okay. Then you should start at 16:45. We have 16:40. How many time do you need, Dr. Markiv?
Can you repeat how many time I need for my presentation?
Yeah.
Approximately 10 minutes, but I hope that everything will be okay with this connection, because today is very bad internet connection. So I hope that everything will be okay. So sorry in advance if I'll be as absent on the spot.
Then let's try to start.
Okay. So I would like, do you see my screen? Sorry. Yes, everything is okay. Okay. So I would like to present our teamwork compensatory methods for measuring phase shift using signals with semi-periodic conversion in diagnostic intelligence systems. It dwells upon phase shift determination method using total signal obtained as a result of summing up two harmonic signals after carrying out semi-periodic transformation. Value of phase shift has been determined by comparing vector obtained after amplitude time analog digital conversion of total signal with a set of reference function vectors. Maximum value of correlation coefficient has been used as criterion for specified vectors coincidence. Algorithms for finding the maximum correlation coefficient has been developed, and in our work, main errors sources for proposed method for diagnostic and determination of modern weapons and military equipment state will allow to reduce requirements for measuring equipment without reducing accuracy of measurements. Apparatus for conducting factorial experiment in our work is like basis for a compensatory method implementation. Factorial experiment, it is the choice of the ratio which is the most fully described the shape of curves, total signal obtained as a result of the summation of two harmonic signals after conducting two semi-periodic transformation. What does we mean under semi-periodic conversion? Under B-semiperiodic conversion of input signals, we mean that input sinusoidal signals turn into two semiperiodic ones with further summation. By form of their phase shift of the received signal, it determines the phase shift. The operation of transforming of sinusoidal signal into two semiperiodic may be done with the help of diode bridge or diode resistive converter. So it's needed to consider measurement procedure by measuring harmonic signals phase shift. Time diagram for signals which have certain phase shift relative to each angle as shown in the previous slide. And after main operations, auxiliary operations should be posed to this process. And after performing amplitude time analog digital conversion, it is possible to obtain different kind of vectors that coincide in the sinusoidal this vector. In order to reduce computational operation and simplify procedure, it is advisable to switch from time counts to signal phase counts. And we can do it with the help of discrete reference function. So apparatus, here in the slide, you can see experiment part of our research, and you can see that algorithm for finding the maximum using Golden section looks like there is previous stage, main stage, and why we should use such maximum, yes. Determination of phase shift coincidence, which is measured and formed by reference function, can be carried out on the basis of criterion of reaching correlation coefficient maximum. So apparatus for conducting a factorial experiment is considered like basis for proposed methods implementation of phase shift measurement of two harmonic signals. And to ensure required accuracy of phase shift measurement, it may be necessary to perform auxiliary operations, as I have said previously, as hardware filtering of input signals in order to reduce influence of interpresence of which is due to the influence of external factors, and their amplification to improve the sensitivity of value measurement after just after it, we have some kind of B-semiperiodic conversion, yes, converter. So taking into account the above mentioned, it is needed to, it was needed for us to formulate what is phase shift in such a way, which is the ratio for determining this value, and it was shown in slides. And so for further research, conducting experiment research with obtaining numerical values is planned not now, but after completion of work on the synthesis of the calculation methodology requirements by computer equipment and software, because without finishing these calculations, it is really hard to conduct experiment research with true numerical values. So thank you for attention.
Thank you very much.
Thank you.
Maybe somebody have a question to reporter.
I'm sorry, but I can't start my presentation.
Yes.
Very good.
I think the presentation was on a difficult topic. So I was wondering in these often the Fourier transform or Laplace transform is used in such periodic systems, like a signal transformation.
Yeah.
And how did you make use of such techniques, or did you do it differently?
Thank you very much for your question. I understand. Yes, this theme is really, for me, it's also hard for understanding. Yes, in general, it's really hard to understand how to solve this question with B-semiperiodic conversion, yes, by this phase shift. So in our work, we try to concentrate not on time counts, but on signal counts, yes. by using such B-semi-periodic conversion. And that's why at the beginning, I proposed our definition, what it is, what we understand under B-semi-periodic conversion, because in general, it is maybe something like more general definition, but we understand that B-semi-periodic conversion of output signals, it's input sinusoidal signal that is turned into two semi-periodic, one with further summation, yeah. And in general, it was a teamwork. So maybe more detailed information can be explained by others representative of our team, yes, because teamwork is some kind of a cooperation, yeah. And speaking the truth, some of our colleagues are in armed forces, and even now I can't even be sure which information is under secret and which information isn't under secret. So if you have some special questions, I would like to ask you, if it's not a problem, to write for my colleagues, especially to Mr. Lavrut or Mrs. Lavrut, yeah, because I don't want to have some misunderstanding with some different point, yes. So,
Thank you very much.
Just in general, to show some formulas, to show something in general, yes, of course, I can show it. And
I see that there's also an additional layer of complexity with respect to the classical signal analysis. Thank you very much.
Thank you.
I have only terminological question.
Okay.
This semi-periodic, it seems to me translation from Russia, because B-semi is together is periodic conversion.
Yes, you know, we also thought about it, and it was two-time signal conversion. Yes, it was some kind of two-level signal conversion, but by studying, it's not like Russian, not like seems like Russian, because we were studying international different articles. And when speaking about Asia and speaking about those people who studied this question before us, B-semi-periodic conversion frequency of using B-semi-periodic is more it's more used in literature. Yes, yes. Not time signal, yes, but by B-semi-periodic. But I understand the question.
I look at two and I find out another translation, not translation, but a term of this signal.
Thank you very much for this. Yes, maybe we will take into consideration and try to correct something. Yes. But I should consult with my team, yes, in order to correct something. Yeah. Okay, thank you very much. Thank you very much. Yeah.
Okay, and then today, not today, but now we have once again some coffee break.
And there will be one presentation after the coffee break. No, there are a few presentations, of course.
Few, of course, few. 1, 2, 3, 4, 5.
Yes.
After coffee break.
So
then we should do how long? 15 minutes of coffee break. Then 5 presentation.
Yeah, we start again sharp.
Sorry.
Thank you for attending, and under these circumstances, every speaker should be thanked for doing all this burden to present under such difficult circumstances.
We should interrupt our connection. We meeting recording also should every time interrupt.